All right, so today we're going to do 12.3. Remember when we multiplied polynomials and added polynomials and subtracted polynomials? And I said we're not going to divide them yet. Today we're going to divide polynomials. All right. Yeah, cricket, that's right. Oh, gracious, thank you. Let's go on and divide polynomials. So we're going to divide a polynomial by a monomial, first of all. And so you have 6x cubed minus 12x squared plus 9x. And we're going to divide it by 3x. Now, what I'm going to show you to do is probably the easiest way of dividing them so that you don't make any mistakes. You pick up your pencil, and you're going to say divided by 3x on each term up here. Because we have to divide everything by 3x. Just like we multiplied everything by 3x, we have to divide everything by 3x. So when you see 6x cubed over 3x and you simplify it, what are you going to have when you simplify that fraction? Melissa?
2x squared.
2x squared. All right. When you take negative 12x squared and you divide it by 3x, you simplify that fraction. Andrea, what are you going to have? Minus 4x. And finally, you take 9x and you divide it by 3x. And, or Angela?
3.
You're going to have 3. You are done.
You don't have to
You don't
simplify
like
anymore.
faster.
No, it just says divide the polynomial by monomial, and we're done there.
Oh, yay.
Isn't that kind of nice?
It's harder. I know.
Right.
It's gonna be really hard. We're gonna think it's super easy. And it's gonna be
Okay, tell you what. Why don't you do this one, please? Okay, you do 12x to the fourth minus 16x cubed plus 20x squared, and you divide it by 4x, please. So we have divided each of the terms by 4x, and we have 3x cubed minus 4x squared plus 5x. That looks like a very good polynomial to be left with. Any questions there so far? All right. Next, we're going to divide a polynomial by a binomial. All right. X squared plus x minus 6 divided by x plus 3. Yes, it looks like long division. Okay. Now, it's not that bad, ladies and gentlemen. Let's pay attention to what's going on here. I think you all can handle it. First of all, your polynomials that you have to be in order from highest degree to lowest degree. So if they're not that way, you need to rewrite them so that they are. As x squared plus x minus 6, highest degree down to lowest degree. X plus 3, highest degree down to lowest degree. Everybody understand that idea first. Okay. Then you are going to look at your first term in each of your polynomials and think, what would I multiply x by to get x squared? X. And that's what I'm going to write up here. So I'm going to write x. Actually, I'm not going to write it above the x squared. I'm going to write it above the x that's over there just a little bit further. Excuse me. It's like when you guys are doing long division, like terms above like terms type of idea. So x times x is x squared. X times 3x. Let me take that back. X times 3? 3x. I was thinking of the answer. So now we get to, what do you do in regular long division? Subtract them. X squared minus x squared. 0. Hang on. And here I'll have a negative 2x when I add those together. Andrea.
Where'd you get the 3x?
I got the 3x from this times this. So I took x times x to get x squared and x times 3 to get 3x. Okay. so that I'm looking at just these two things so far. Okay. Process here. Okay, so we're looking at how many times does x go into x squared? It goes in there x times. So I got x times x gives me x squared, and x times 3 gives me the 3x. Then I can subtract them, and I've dropped out my x squared terms. X minus 3x gives me negative 2x. Bring down your minus 6. Just like we do in line division, we'll bring down the next number. We'll bring down the next term. X times what gives you negative 2x? Negative 2. So up there on top, we're going to write minus 2. And then we have to multiply that by our binomial. So negative 2 times x is negative 2x. What's negative 2 times 3? Negative 6. Now we have to subtract these, right? So that changes our signs. And what are we left with?
0.
Oh, perfect. Then our answer is x minus 2. That is our quotient. Oh boy. That's not going to take a while. You guys, it's a new process that you haven't seen before. This is one of those soaker things. That's why I'll teach some now, and I'll teach it more next Wednesday. Okay. Let's go through another problem together like this one. Yes, we should. Let's do x squared plus 3x minus 4 divided by x plus 1. When you start out with this, that first term, x, you have to look at how many times does it go into x squared? What would I multiply it by to get x squared? X times x. So we're, as always, since I have two terms here, I'm going over to the end of that second term there to write my x up above. And now you have to multiply that term that you wrote up in the quotient times your binomial to see what are you left with here. So x times x gives you x squared. And what's x times 1? X. And then we have to subtract this just like we do in normal long division. Right.
How do you put negative x?
I have to subtract the entire polynomial from the one up above. So I did x times 1 gives me positive x, but I notice I use my red pen to show that I'm subtracting that entire polynomial. Okay, Trent? So x squared minus x squared, we want those to drop out. We want to be done with those. What's 3x minus x? 2x. Bring down the minus 4. X times what gives you 2x? 2. So I want to go plus 2 on top. So now I got to take that 2 times all of this stuff up here. So 2 times x is?
2x.
And 2 times 1 is?
2.
Oh, got something going on here. I'm going to subtract both of them. And what am I left with?
Negative 2.
Negative 6. Now this is going to be a little different. We're going to write this as x plus 2. This thing down here is called a remainder. You guys know that word, right? Hang on. And what I'm going to do is I'm going to write the remainder. You remember how you always write the remainder as a fraction? The remainder over the divisor.
Oh.
So you're going to write it as 6 over x plus 1. Yes, it is minus. Oh, thank you very much. Minus 6 over x plus 1. Oh, I like that.
It's not impossible.